Step back 300 million years to the Carboniferous period, a planet unrecognizable. Earth's atmosphere during this era possessed a dense, highly reactive chemical mix. Massive fern forests pumped atmospheric oxygen to an astonishing 35%. By comparison, modern air contains a stable balance of just 21% oxygen. This hyperoxygenated blanket transformed the fundamental rules of biology. Trees grew to colossal heights without modern fungal decay to slow them down. Insects, breathing through spiracles, absorbed oxygen directly into their blood. Meganeura, giant dragonflies with 2-foot wingspans, dominated the humid skies. Massive Arthropleura millipedes crawled through the thick forest floor litter. Yet, this oxygen-heavy atmosphere harbored a violent thermodynamic threat. Oxygen acts as the ultimate electron acceptor, accelerating chemical combustion. In 35% oxygen, the minimum energy required for ignition drops drastically. Organic matter became hyper-flammable, akin to fuel-soaked timber. Even living green foliage carried enough oxygen potential to ignite directly. Electrical storms were frequent due to high atmospheric pressure and humidity. A single lightning strike could trigger an instantaneous chain reaction. The stage was set for fire events on a scale unimaginable today. Fire behavior in high oxygen violates standard wildland fire dynamics. Modern fires choke when oxygen supply drops below critical thresholds. Prehistoric fires had a virtually unlimited supply of atmospheric oxygen. Combustion fronts moved at velocities exceeding severe gale forces. Geologists find widespread fossilized charcoal deposits from this exact era. Deep rock strata contain thick, continuous bands of dark soot particles. These layers prove that prehistoric forests burned repeatedly on a global scale. This unique atmospheric condition gave birth to the ultimate inferno, the firestorm. Thermodynamically, a firestorm is a self-sustaining combustion engine. It starts when localized fire core temperatures cross critical thresholds. Temperatures inside the core rapidly escalate beyond 1,200 degrees Celsius. Extreme heat causes the air column directly above to expand violently. Superheated air loses density and rushes upward at extraordinary speed. This upward surge forms a colossal atmospheric chimney effect. As air shoots skyward, a severe low-pressure vacuum forms at ground level. Surrounding cool air rushes inward from all directions to fill the void. These inflow winds quickly accelerate to hurricane-force velocities. In a 35% oxygen environment, this wind delivers immense oxygen fuel. The increased oxygen feed spikes the combustion reaction to nuclear intensity. A runaway thermodynamic feedback loop is permanently locked in place. The firestorm no longer obeys prevailing regional wind directions. It generates its own violent, localized meteorological weather system. Inward gale winds exceed 150 miles per hour, uprooting ancient trees. Thermal updrafts trigger massive spinning fire tornadoes within the core. These fire whirls stretch hundreds of meters high into the churning dark sky. Acting like massive thermal blowtorches, they instantly incinerate all organic matter. Intense radiant heat from the smoke canopy ignites vegetation ahead of flames. Flashovers occur across square miles, igniting entire forests simultaneously. Soil moisture vaporizes instantly, building explosive underground steam pressure. Dense river rocks shatter and explode from extreme thermal expansion. Combustion rapidly consumes available ambient oxygen within the central core. This leaves a death zone of total asphyxiation at ground level. No breathing creature can survive inside this atmospheric furnace. Across the Carboniferous landscape, these firestorms reshaped whole continents. Primeval peat swamps were systematically incinerated down to the waterline. Massive peat beds caught fire and smoldered underground for decades. Subterranean fires cooked root networks and completely sterilized the soil layer. Above ground, thousands of square miles of forest were erased in days. Giant flying insects were trapped by superheated, turbulent air currents. Strong thermal drafts knocked creatures out of the sky into the flames. Massive land arthropods were suffocated as oxygen was consumed rapidly. Massive heat rising formed terrifying pyrocumulus cloud structures. These supercharged clouds produced dry lightning, igniting fires miles away. Fire easily jumped natural barriers like wide rivers and open lakes. Updrafts lifted heavy burning logs high into the upper atmosphere. Falling firebrands rained down over distant unburned canopy zones. Entire terrestrial ecosystems were reset back to ecological zero. Yet, this brutal destruction acted as a major driver of the global carbon cycle. Unburned plant carbon was buried rapidly under heavy layers of mineral ash. Deep burial over geological time compressed this carbon into thick coal seams. Modern coal reserves are the direct physical remnant of ancient firestorms. Without prehistoric hyperoxygen fires, global coal deposits would be minimal. These megafires served as an emergency atmospheric pressure valve. Mass combustion consumed atmospheric oxygen and released carbon dioxide. This feedback prevented oxygen levels from rising to lethal higher limits. The atmospheric system self-regulated through cycles of utter destruction. Early terrestrial life survived only by adapting to this violent rhythm. Fire was not an anomaly. It was the planetary atmospheric thermostat. Could a hyperoxygenated firestorm ever occur in our modern atmosphere? Combustion scientists study this physics using specialized pressure chambers. Sealed chambers allow precise control of oxygen percentages during testing. At our current 21% oxygen, dry pine burns at a controlled, predictable rate. Increasing oxygen to 25% causes burn rates to double immediately. At 30% oxygen, combustion becomes violently explosive and deafening. Flame core temperatures jump by hundreds of degrees within milliseconds. Materials rated flame retardant burn effortlessly under elevated oxygen. Moisture-soaked green vegetation ignites without requiring any prior drying phase. These tests confirm the extreme fragility of Earth's modern atmospheric balance. If atmospheric oxygen rose by just 4%, global forests would vanish. Uncontrollable planetary wildfires would sweep continents on a seasonal basis. Modern history provides rare, terrifying glimpses of localized firestorms. Intensive urban bombing in World War II created localized firestorm conditions. In Hamburg and Dresden, concentrated heat ignited true firestorm physics. Thousands of individual building fires merged into a single thermal column. Inward winds reached hurricane velocities, uprooting trees and collapsing walls. Street asphalt liquefied and ignited purely from intense radiant heat overhead. Ambient oxygen was stripped out of shelters, suffocating victims instantly. These historical catastrophes occurred under normal 21% oxygen levels. They demonstrate the sheer lethality when fuel and thermal energy concentrate. Scale that urban catastrophe up across an entire hyperoxygenated planet. That is the terrifying reality the prehistoric biosphere faced regularly. Oxygen is the ultimate paradox, the giver of life and its destroyer. The boundary separating a thriving planet from global fire is razor thin. Firestorms do not end at the burn boundary. They trigger planetary climate feedback. Powerful convective updrafts inject millions of tons of soot into the stratosphere. Stratospheric black carbon reflects incoming solar radiation back into space. This triggers a rapid planetary cooling event known as a fire winter. Global surface temperatures plunge drastically within months of major fires. Photosynthesis collapses as solar energy reaching the surface drops. Surviving plant life enters prolonged dormant states in the cold darkness. Over decades, stratospheric soot gradually settles back to the surface. Massive atmospheric carbon dioxide released by fire then takes over climate. Extreme greenhouse warming replaces the winter, causing severe global droughts. Desiccated vegetation sets the perfect stage for the next global fire cycle. Prehistoric Earth swung violently between intense freezing and extreme heat. Oxygen levels functioned as the master catalyst for these climatic swings. At the Cretaceous-Paleogene boundary, firestorms reached global extinction scales. The Chicxulub asteroid impact 66 million years ago launched high-energy debris. Superheated impact ejecta re-entered the atmosphere across the entire globe. The upper atmosphere radiated heat equivalent to an industrial broiler for hours. Spontaneous global firestorms ignited across every continent simultaneously. Global forests were incinerated within a single horrific 24-hour period. Large dinosaurs had no natural defense against intense thermal infrared radiation. Small subterranean creatures survived inside burrows insulated by damp soil. Global firestorms were a primary executioner in wiping out 75% of species. Thermal radiation proved more lethal than the immediate impact shockwave. It demonstrated the catastrophic capacity of Earth's atmosphere when energized. The darkest face of atmospheric oxygen was fully unleashed upon biosystems. Today, Earth's oxygen concentration rests at a stable 20.95%. This specific concentration is not a random environmental coincidence. It is actively governed by a complex planetary biological feedback system. Oceanic phytoplankton generate over half of all global atmospheric oxygen. Terrestrial forests continuously balance oxygen production through photosynthesis. If oxygen dropped below 16%, natural fire combustion would cease entirely. Without fire, dead organic litter would accumulate, choking plant regeneration. Essential mineral nutrients would remain trapped indefinitely in unburned biomass. Conversely, if oxygen reached 25%, wildland fires would be unstoppable. Ecosystems would burn far faster than plant life could ever regenerate. Our current 21% level represents the absolute Goldilocks zone for life. It permits beneficial fire clearing without destroying continental biomes. Normal wildfires act as nature's essential mechanism for forest renewal. Ash deposits recycle vital bioavailable minerals directly into depleted soils. Canopy openings allow sunlight to reach seedbeds on the forest floor. Modern climate change, however, threatens to disrupt this functional balance. Rising planetary temperatures drive unprecedented droughts and dry fuels. Modern extreme megafires are exhibiting dangerous firestorm behaviors. Fire whirls and pyrocumulonimbus lightning events are escalating worldwide. Studying prehistoric firestorms provides critical insight for planetary management. Earth's geological record holds the ultimate blueprint of atmospheric power. Oxygen remains the invisible chemistry that forged our living world. Preserving atmospheric stability is mandatory for human civilizational survival. Beneath the calm air we breathe slumbers an ancient thermodynamic force, a constant reminder that life flourishes only by the grace of atmospheric equilibrium.